Right, in the previous lecture we had a look at the employees and their managers' names by using a self-join. In this one we're going to look at a really difficult puzzle. How many bosses does a person have? So if we have a look at the table that we had last time, this person 1125, he has a boss, so that's 1. Person 223 has another boss, 2. Person 133 has a boss, 3. Person 124 has a boss, 4. Person 123 doesn't have a boss. So this person down here is 4 levels down the chain of command. How can we work this out? This is one of the more complicated bits called a recursive CTE. Now all a CTE means is a with statement. So a CTE is the same as a with statement. So why in the objectives for this exam they've chosen to put CTE statements separate from a with statement, I have no idea. I'm only assuming that they mean a recursive CTE statement, which is what I'm going to show you here. So the first thing is we need a new column for boss number. So let's start with our with. So with my table as open bracket, close bracket, and select star from my table. So we want all of the people that don't have a boss. So select star from table employee where manager is null. And specifically what I want is the employee number, but because I've done star it's easier for me to fill this in, the first name and the last name. Okay, so now we can run that. We get just one person. Now there is one difference from the code that we did last time in this. There's a semicolon at the end of an update statement. The reason for that is if I try running this without the semicolon, we'll see that there's incorrect syntax near the keyword with. If this is a CTE, a common table expression, or other things you don't need to worry about, then the previous statement must be terminated with a semicolon. So this is one of those instances where semicolons are mandatory. So here we have that one person. And he, or she, it's Jane, has a boss level of 0. So we can put that in. Now, you remember these subqueries which called on the main query. They were correlated subqueries. The answers subquery in some respects depended on the main query. Well, it's going to be the case here. What we're going to do is now take what's left of the table employee and join it with my table. So imagine that table employee has these 1005 rows. We've just moved one of them out into my table. So we've still got 1004 rows left. So here we have table employee and here we have this new table. So my table, I can't remember what I've called it. Just my table. And that has an employee ID, it has the names, and it has a boss level. So what I've done so far is take out this top row which has a manager of nil out of table employee and into my table. Now obviously it doesn't actually physically remove it from table employee. This is just a demonstration as to what's happening internally. Once the select statement is over, table employee you'll find has always been the full thing. It's just it's made a copy and it's starting to delete it. Well, what we need to do now is do a join from table employee to my table, so that where the manager is equal to the table employee, then we give that boss level, the boss level of the manager, in this case 0, plus 1. And then we need to take all of those out of table employee into my table, and then we join what remains in table employee, join it with my table, and give the boss level as whatever the boss level is here. So 124 is this one, so boss level 1, so equals 1 plus 1. And then we move all of that lot out, and then we do again and again and again. That's why it's recursive. It happens again and again and again. So let's just concentrate on the first lot. So we have got this one out, and we want to get these equally out. So currently these are all contained here. And we want to move them across, and while we're moving across, we want to give the old boss level plus 1. So let's write that in here. So we have this initial table, which is just got this one line left. It's just this one line that we've moved across from table employee into my table. So now we're going to union all that with what's left. So what's left, and because it's union all, we have to use exactly the same columns. Employee first name, employee last name. I'll work out what to do with boss level in a moment. From table employee. And we're going to join table employee to the outer table, to my table. So join with my table, the with table, on. So what are we joining on? Back to our Excel. We are joining employee table manager with my table employee ID. Okay? So we're joining manager equals to this new table employee number. Now what we're going to do here is we're getting the boss level from my table. So my table.boss level, and we're going to add 1 to it. Okay, so that we now see we've got ambiguous employee number, employee first name. It doesn't know whether we're going from table employee or this with my table. So we've now got to tell it, well, we don't want to get any of these from my table. We want to get it from here, from table employee. So we need to alias it. So we need, well, not alias it, we need to give it the table, which we just happen to have aliased. So there we go. So that moves that lot across and gives it a boss level of 1. Now comes the magical part. It then does this again. So I don't have to write any more code. It then looks at what's remaining and does exactly the same thing. We have a reduced table employee and an increased my table. So now it sees, oh, there's a join here. Let's move these across as well. And let's give this a boss level of 1 plus 1 equals 2. And it goes through the entire table like that. And I don't have to do anything more. That is the entirety of the statement. So let's see what the answer is. The answer is what exactly we're hoping for. The first person had a boss of level of 0. The next one's a boss level of 1. We have a boss level of 2. Go further down with boss levels of 3. And then right at the end, we have boss level of 4. So all we have to do is write the bit where we don't have to do any more computations. This is called the anchor. So this anchors the table with some data. And then we union what's left. So we're using the same table reference. We're joining it with the CTE, the common table expression, the with statement. And we're joining it so that we can identify connections between what's left and the anchor. And then it will keep going. And when does it keep going until? Until this lot returns 0 rows. So it doesn't keep going indefinitely. At some point, everything in this Excel table here will have been copied across. At least that's the hope. And when that's done, we now have a complete My Table, and we can select from it and we get the results here. That is called a recursive CTE, common table expression. It can be a lot to get your head around. But just remember, we start off with this anchor part. We union all, and we have the recursive thing. And you'll find it's so much easier if you can get a piece of paper like I've done here in Excel, get your data, and work out what exactly you want to do, what you want to happen. And it's got to be the same thing that happens each time. So that's why we said just add 1 to the boss level, because that's what happens at each level. So that is recursive CTEs.